All right, so let's take a look at question 6 from section 1.4. So starting with part A, so we're given a lot of data about some function, specifically some values of some points and what the value of the derivative is at those points. So let's use that information to do a couple things. First, they're asking us to graph what the function f looks like. And then we want to come up with a formula for that function. So it's algebraic definition. So first things first, we're told some information about the values this function takes. So we know this is a point. Actually, that's the only point we know. So we'll go ahead and start there. So f of -2 equals 1. So we know this is a point on our graph. What else we know? We also know that f prime of -2 is -2. So what does that mean, f prime? So that is referring to the derivative. So we know that f of -2 is 1. So we know that's a point on this graph. But the derivative also tells us something about how the graph or how the function behaves there. So at this point, -2, x equals -2, we have an instantaneous rate of change of -2. Graphically speaking, we can think about that as being the slope of a tangent line. So what does that slope look like? Oops, stop doing that. So that is, roughly speaking, the slope of -2. So not sure how my graph looks yet, but I know it's going to have a slope there of -2. So I believe I've handled this condition and this condition. So going a little further, we're given more values of the derivative. F prime of -1 is -1. So I know when x was -1, we have a slope of -1. So maybe before we put that slope in there, we should figure out what this looks like. So if I have, actually, we'll just put the slope in a few places, and from there, we'll figure out where this graph actually goes through. So this is a key idea. Like while I'm marking a few slopes here, this is one of the key ideas from this section is understanding how a function and its derivative are related. So in this case, f of -2, that tells us where the function is, like where its points are. The derivative tells you something about the covariation of those points. So how rapidly is the y value changing with respect to changes in the x value? So that's what these derivatives that these little slopes that I'm graphing here, that's what those represent. Okay, so for now, I think I've dealt with this derivative. Moving on, we have f prime of 0 equals 0. So at x equals 0, what does the slope look like? So it's going to be horizontal. So I'll throw in a few horizontal line segments in here. But we know when the curve we're about to graph comes through here, it needs to be horizontal. All right, moving on, f prime of 1 is 1. So again, the reason I'm drawing so many little slope lines is because I don't know where this graph is going to be, but I know that when it comes to these x values, the slope is going to have to uh, be what these conditions say that it is. And finally, f prime of 2 is 2. So when x equals 2, we're going to have, this behavior, steeper slopes. So those are all the conditions that I've been given in part A. So now let's use that information to kind of sketch this graph. So I think I can do that. So based on, the only point I know about is -2, 1. So what happens from there? So before I draw anything, let's look at these different slopes I've drawn and think about what's going to look like. It looks like this graph is going to start off by, decreasing pretty steeply, and then it's going to come to a horizontal tangent line at the origin, or so not necessarily the origin, but at the y-axis, and then it's going to start to increase. It's going to start to go back upward. So what's that going to look like? So it looks like it's going to dip below. So here is what I have for part A. So this very much looks to me like it's going to be a parabola. So have a parabola opening upwards. Based on my slopes, it looks like it crosses the y-axis at negative 0.5. But I think we have met this part here. We have, based on the very limited data we're given, this is what this graph looks like. I'm very confident it's parabola as far as, how high or low it is or how steep it is, or, how steep the sides are. I'm not sure about that, but I think I have a pretty good representation so far. So from there, I want to move on to part B. We want to figure out a formula for this this parabola. So let's see how we can do there. I know it's a parabola. So what form do those take? So y equals, I'll give you a couple forms here. I know I'm going to have a squared x term. Then it leaves us to kind of find these things here. But what if we, kind of look at if we look at what's called, vertex form or completed square form, this might be a little easier to think about, because if I can isolate where the vertex is, so on a parabola, that's either where, it comes to a minimum or where it comes to a maximum. I have a minimum, and it looks like that minimum is where I have a vertex at 0, and I said negative 1/2. By the way, your graph might look a little bit different from mine, just because, like I said, we have very limited data to go off of. But I think the parabola is something we want to focus on. So we have a vertex at 0, negative 1/2. I'm just going to say, for simplicity's sake, that A equals 1. Again, right now, this is kind of an estimate, kind of a guess. Let's see where we go from here. So y equals x minus 0 squared minus 1/2. So for now, I'm saying that my formula is this. F of x equals x squared minus 1/2. So that's a conjecture. Conjecture is a fancy math word for give me your best guess, give me your most educated guess. So the rest of the part B here, I'm going to get a new slide, but this is what I want to investigate. I want to see if this f of x equals x squared minus 1/2 is meaningful here. So based on this parabola that I made, so that's our graphical evidence, let's look at finding the derivative here. I put the slides in here backwards, didn't I? Excellent. That's okay. So we have f of x equals x squared minus 1/2. Let's try to find a derivative. What is f prime of x? So we're going to use the limit definition of derivative here. So the limit as h goes to 0 of f of x plus h minus f of x all over h. So again, this limit definition is general for any function. So now how do I apply it to the function I care about? Well, if f of x is x squared minus 1/2, then f of x plus h is going to be x plus h squared minus 1/2 minus f of x, which is x squared minus 1/2 all over h. So I get the limit as h approaches 0, and now I'm going to start expanding some of these brackets. X squared plus h squared plus 2xh minus 1/2 minus x squared plus 1/2 all over h. Very conveniently, I get my 1/2 to cancel. So what's the limit I'm left with? X squared plus h squared plus 2xh all over h. Oh, I also have the x squareds canceling. So I really just have h squared plus 2xh over h. And hopefully this is not a surprise by now that we have an h in common in the numerator. So I can factor that out and get h times the quantity of h plus 2x over h. These h's cancel. And now I'm in a place where I can do direct substitution. And I get my derivative of 2x. So now what we'd like to do is, so here's what we have. We have f prime of x equals 2x. Let me put a question mark here because let's see if that actually matches the information we have. So we have f prime of x equals 2x. Does that fit any of our data? Well, we had said that f prime of -2 equals -2. For us, that would be -4. So not up to a good start, but let's keep looking. So let's make a table here. We have x. We have the f prime of x that came from part A. And the f prime of x that came from, I'll say required, because that's what is given in the problem. So what values do we have derivatives for? We have -2, -1, 0, 1, and 2. I'll get too close to the bottom of my slide here. Let's just do those four for now, since I can't reach the bottom here. So our derivatives that are required are -2, -1, 0, and 1. What's going to come from our formula that we came up with? Well, what's going to come out from that is -4, -2, 0, and 2. So what's the difference between what we conjectured and what we should have come up with? Well, it looks like the derivative is actually just simply x. So let's think about it this way. We said f prime of x equals 2x. What we really should have gotten is f prime of x equals x. So it might seem like we were off by quite a bit, but what's more valuable here is that we're relating a derivative. We're relating the derivative of f to what we know about f itself. In both cases, we got something linear. The derivative is linear, which is going to lead us to a parabola, which is, what we know we constructed in the first part. So again, I'm not as concerned with the fact. I'm not as concerned with the idea. Can you get the exact derivative based on this very limited data? But hopefully this makes sense kind of how we're walking through it.